Hello everyone, welcome back to my YouTube channel. In today's video, we are going to discuss about Unit 4-5 most important questions which are comes in your exam and which are asked in your previous PYQs as well. So these are the questions of database management system. So let's start. The first will be Unit 4, which is here is a 2 marks questions like short questions of transaction and concurrency. So the first question will be asset property, as we know this is important question, and define a transaction. What is deadlock and use a log file? What is the use of log file? So let's talk about them. The first question will be, what is asset property? So asset property is basically a set of properties that guarantee a database transaction is proceed reliably. Like A stands for atomicity, like the transaction will be like fully successful or neither be started, so all or nothing. And the C will be consistency, database remain in a valid state. I stands for isolation, like transaction don't interfere with each other. Every transaction simultaneously execute but don't interfere each other. And D is for durability, like changes are permanent after a commit. And the second question will define a transaction. So a transaction is a single logical unit of work that performs several operations like read or write on a database. It must begin and end as complete unit. The third question will be schedule in database. So a schedule is a sequence of operation like read, write, commit, abort from one or more current transaction. It represents the order in which operation is executed. And we have paging as well. It is recovery technique where the database is considered made up of fixed size pages and two pages table are maintained. So the current page table and the shadow page table, during crash the shadow table is used to restore the state. These are the long questions of Unit 4, which is asked in 7 marks or 10 marks. So the questions will be describe the transactions state diagram like active, partially committed. These are the states which and this diagram I provide you in Unit 4, so you can see there. And the next question will be conflict serializability. How do you check if a schedule is conflict serializable? And discuss two-phase locking protocol and advantage disadvantage as well, and log-based recovery also. So let's talk about them. The first question will be describe transaction state. So a transaction goes through several states during its lifetime. So understanding this is crucial for recovery. The first state will be active state, the initial state where the transaction execution operation starts. The next state will be partial committed, where the state after the last operation is executed but before it is saved permanently, like committed. And the third state will be committed, where the trans state after successfully completion changes are now permanent. And failed, the state if normal execution can no longer proceed due to error, so the transaction will be coming to the failed state. And the last state will be aborted state, where the state after the transaction has been rolled back and the database is restored to its original state. So these are the states of transaction state diagram. The next question will be explain conflict serializability with an example. So a schedule is conflict serializable if it is conflict equivalent to serial schedule where transactions run one by one. Let's talk about the conditions. So conflict serializability conditions are two operations from different transaction conflict if the access of the same data item like X, they both get access and at least one of them is right X operation. The next will be testing serializability, which is we use precedence graph like create nodes of each transaction like T1 and T2 and draw an edge of T2 like T1 to T2 if a transaction in T1 conflicts with an operation like in T2 and T1 occurred first. Like result will be if the graph has no cycle, the schedule is conflict serializable. The next question will be recoverability and in schedule. So even if schedule is serializable, it must be recoverable to handle system failures. Like recoverable schedule, a transaction Tj should only commit after any transaction Ti that Tj has like read data from as committed. And cascadeless schedule, like a transaction should only read data that has already been committed by other transaction. This avoid cascading aborts, like where one failure force many other transaction to roll back. The third will be strict schedule. A transaction can neither read nor write a data like item until the last transaction that wrote it has committed. The fourth question will be explain log based recovery, like deferred versus immediate update. As we discussed in previous videos, the log is a sequence of record keeping track of all database updates, referred updates like no undo, redo. Update are not returned to the disk until the transaction committed, and if the system crashes before commit, no cleanup is needed, like no undo. And if it crashes after commit, we use a log to redo the changes. The next will be immediate update, like update are applied to the database as they happen, and if the system crashes, we must undo commit uncommitted transaction and redo committed ones to ensure consistency. These are the questions of unit 5, which is concurrency, control and recovery. So let's talk about them. What is checkpoint in recovery? Define log granularity, SGA in Oracle, and role of control files in Oracle. So we talk about like Oracle architecture. So the first question will be, what is deadlock? So deadlock is a state where two or more transactions are stuck in a circular wait, each holding a resource that other needs and neither can proceed. Example will be T1 holds lock and A and waits for B. So T2 holds lock on B and wait for A. So this is deadlock. And the next question will be define log granularity. So granularity refers to the size of data item being logged. If you want to study in detail, you can refer unit 5 of this. So fine granularity will be locking a single record row, high concurrency and high overhead, and coarse granularity will be locking an entire database or table, like low concurrency and low overhead. The third question will be, what is use of checkpoints? So a checkpoint is a record in log file that indicate all previous transactions have been safely written to the disk. During recovery, the system only needs to look at the log after the last checkpoint saving time. So these are checkpoints. Name the memory components of an Oracle system. So memory components are SGA, which is system global area, shared memory for all users, and PGA will be program global area, where private memory of a single server process. So these are the components of Oracle instance. Let's talk about long questions which of like you ask in 7 marks or 10 marks. So unit 5 questions will be explain deadlock detection and prevention techniques like wait die and wound wait. And second question will be describe the Oracle architecture, logical and physical structure, recovery process using shadow paging, and detailed note on multi-origin concurrency in Oracle. So let's understand these questions. The first question will be two-phase locking that I not discussed earlier. So this is two-phase locking, ensure all schedules serializable by requiring the transaction acquire all logs before realizing, and it has two phases like growing phase, shrinking phase. So the transaction can obtain logs but cannot release any, and the transaction can release logs but cannot obtain any new ones. So 2PL prevents inconsistency but does not prevent deadlock. You can refer this in unit 5, so you can check out from there. The next question will be explain deadlock detection and prevention techniques. So prevention technique, let's talk about first. So uses timestamp to decide who waits. So wait die will be T1 like older and requests data held by T2 younger. So T1 waits. If T2 younger, request for T1. So T2 die like rollback. And the wound wait will be older T1 wound like preempts younger T2 younger and wait for older T1. So these are the things. And detection, when we talk about detection, the system maintain a wait for graph. So if the graph consists a cycle, a deadlock is detected and the system then pick a victim transaction to roll back. The next question will be describe the Oracle database like logical versus physical. So Oracle is the most popular commercial Dbms relational database management system. Its architecture is divided into logical and physical. The logical structure will be table space like logical storage unit, system or users, and we have segments like a space of specific objects like a table or index. Extents like or blocks, so smaller unit of logical space. And when we talk about physical structure, we have data files like store the actual data, control files store metadata about the database, and redo log files like store changes for recovery. The fourth question will be, and the last question of this video will be, explain multi-version concurrency control, MVCC. MVCC is used by Oracle to allow high concurrency, and the concept inside this will be, instead of locking a row while it's being updated, the system keep multi-version of the data. The benefit of this is basically reads never wait for writers. When a user is updating a row, other user can still read the previous version of that row from the undo segment, and this ensures that the database is always available and consistent without making user wait for logs. So there will be creating a snapshot, so the writer will not wait for reader. All these things are in unit 4 and 5, most important questions. If you like this video, thanks for watching. Thank you.